Graham, thank you very much for being on the podcast.
Yeah, thanks for having me. I appreciate it.
Yeah, we're obviously going to be talking about alien life, but before we start, maybe you can tell us a little bit about yourself and astrobiologists in general.
Yeah, absolutely. My name is Dr. Graham Lau. I'm also known online as the Cosmobiologist, which just was an accident. I was naming a blog back in 2010 and happened upon that name, and then people started calling me that, and so I was like, well, okay, I'll take it. Astrobiology is a really remarkable field, and to me, astrobiology is the culmination of everything we humans have been doing in science and beyond for the past few millennia in trying to understand who and what we are and our place in the cosmos. For a long time, we had terms like xenobiology and exobiology. Some of your audience might have heard those terms. Astrobiology is a fairly new term. It was first used for a book written in the Soviet Union, I want to say the 1950s, as a scientific term, but it wasn't adopted by NASA until 1996, when a very famous announcement was made by Bill Clinton in the White House. Some research had come out from David McKay and his colleagues, suggesting they had found evidence of life in a Martian meteorite called the Allen Hills meteorite, or ALH 84001. And that potential detection really launched astrobiology for NASA. Um, Now, since that time, a lot of scientists have said that most likely what we thought might have been life in that meteorite probably wasn't. There are abiotic or non-biological explanations for what they found, but the term has kept on, and I think astrobiology has really grown a lot. I speak now to people in Morocco and India and Turkey and Australia and the UK, the US, Canada, Mexico, all over the world. And I'm constantly speaking with young people who not only have heard of astrobiology, but they are trying to sculpt careers in astrobiology. They want to become astrobiologists. And I think for many of us, my generation, we were inspired by people like Carl Sagan. I was inspired a lot by Star Trek growing up. And now I think the future for astrobiology is extremely bright. I think if there is alien life out there, we're very close to a detection. And astrobiology is the realm of studies of people coming together who are going to make those detections.
You said if there is life out there, what's the likelihood that there is and or there isn't? What's your and by the way, have you encountered any alien yet?
No, I have not encountered an
Okay,
alien
bye
yet.
bye. Now that's
And even though I do understand people's personal beliefs when they feel they've seen something they can't explain, they feel that the aliens are out there, but we really don't have any definitive evidence yet that aliens do exist. And as much as I want to believe, I want to believe like an X Files, Mulder and
yeah.
Scully, I want to believe. I also want to know, and there's a really big difference. And astrobiology is about trying to find out. It's about wanting to know. And the sad truth is to use logic and to think scientifically and philosophically, we have to admit, based on our current knowledge, that we could be alone. There is a chance of that. We don't know how much of a probability it is, but there is a chance that life just remarkably just happened this one time in this one world in our universe. And if that's the case, that'd be really good for us to figure out at some point, because it'd be really important to know, one, for our explorations elsewhere, and two, philosophically, I think we would have a moral imperative then to not only preserve life, but also to send life out to the stars. However, as an astrobiologist and as someone who's been a nerd for science fiction and for aliens throughout my entire life, um, I want to believe that there is alien life out there. And when you start looking at just the sheer number of potential environments, the sheer number of worlds, if we look at our galaxy alone, we might have something like 100 billion to 400 billion stars in our galaxy. We don't know for sure, but there's a very large number. And we think right now, based on the current exoplanets we've discovered, that there's something like 1.6 planets per star, which means there could be, well over 600 billion or 700, 800 billion, maybe even a trillion planets in our galaxy. And if even as just a very small fraction of those have life, I mean, it becomes overwhelming how many biospheres there must be out there.
And there are billions of galaxies, right?
Oh yeah, but there's also many hundreds of billions of galaxies too. And so the potential for alien life, I mean, there's just so many, the numbers become so staggering when you start thinking about the possibility. And you might have heard this phrase before, made famous by the movie Contact, based on the movie, the novel by Carl Sagan, that if we are alone, especially when you consider the sheer number of worlds, then it really does seem like a waste of space.
Yeah.
It's just there's so much out there. Like, why would we be alone?
But those figures are incomprehensible. I don't understand. Like when you start thinking about like I woke up today, I had breakfast, and but you think about it from a perspective of this event relative to universe. I'm like, my God, I don't know. Well,
I mean, it's not in our we humans, even scientists, we spend our lives thinking about big numbers and very small numbers too, very small scale things. And yet our minds weren't really evolved to think at that level, to process what a trillion or hundreds of trillions of planets, we can't even imagine, what that, how many that really is inside of our minds. We need to make analogies to other things we actually can understand.
do you think one of the reasons we don't know about life somewhere in the universe, we don't even know what to look for? Does it have to look like the life we know, or it might be something different?
It definitely does not have to be life as we know it. We have a lot of reasons to think that if there is alien life out there, at least some of that life will probably be something like us. Some of the things that life as we know it does makes a lot of sense from the physics and the chemistry. Using water as a solvent. The physics of water, I mean, water is an incredible molecule. And the physics of water, the chemistry of water that allows it to be the solvent of life. There's a lot of really peculiar things about water. The range at which it's a stable liquid, the temperature range is actually really good for planetary surface processes. The way that it can allow for electrical charges to happen inside of fluid spaces, the way that water creates basically cages and helps molecules and stuff move through it, surface tension of water, things that allow it, for instance, to go up through plants, and there's just so many things about water that are incredible. So we have a good reason to think that if there is alien life out there, there's a good chance it's also using water as a solvent. But there's also other solvents. It could be methane or ethane. Supercritical carbon dioxide has been proposed as a possible solvent for life. And then also, life as we know it uses carbon bonds. We are organic beings. We use the chemistry of carbon. Carbon atoms bonded to other carbon atoms, making these large molecules. But there are other potential options. For instance, silicon-based life. On the periodic table, silicon is just below carbon, and it actually has a lot of very similar chemical properties. Silicon can also make long, branched out structures with multiple silicon atoms. And so maybe there's a silicon-based life form out there. But some of the things that life as we know it, the things that life does, we can presume that there's a good chance at least some alien life is probably doing the same stuff. And so that gives us at least something to look for out there.
And when we talk about potential life, what do we look for? Is it our solar system? Is it outside? And what is exactly are we looking for?
Definitely both. It's only in the last 26 years now, since roughly 1995, that we've been discovering worlds, exoplanets around other stars that are in what we call the main sequence. They're sun-like stars, or stars that are kind of in the main branch where most stars kind of exist. They're not super massive stars, and they're not white dwarfs that have burnt out long ago.
Mhm.
But it's only since 1995 that we've been doing that. And we've discovered thousands of these worlds, over 4,400 the last I checked, and that number is probably even higher than that now. And so we are looking at these worlds around other stars. There are a lot of great projects going on right now using telescope data from space telescopes, from ground-based telescopes, and even planning on the future, the next generation space telescopes like the James Webb Space Telescope, or others like LaVoir or HabEx or the Life Telescope, that are in concept and planning and design right now. And so we are looking at these other worlds, but what we're really looking for in those worlds right now is just looking at their atmospheres. Right now, we can't image the surfaces of those worlds. If they have oceans, we can't see those oceans right now, but we can see their atmospheres. And so that's where that kind of realm of astrobiology and looking for signs of life in these alien worlds is at. We're looking at their atmospheres. We are also actively looking for things like technosignatures, listening for radio communications out there, looking for signs of things like a Dyson sphere and that kind of stuff. But I would say a lot of what you hear about in astrobiology really comes down to what we're doing right now in our solar system. We're looking at worlds like Venus and Mars and Europa and Enceladus and Titan and all these other really wonderful candidates for potential life right now in our solar system, or to have signs of past life. So for instance, we go to Mars. There could be extant life on Mars, currently active living things. But in general, a lot of what we're looking for on Mars are extinct, dead organisms from long ago, or the signs left over by them, things we call biosignatures that are left in the Martian rock for us to look at with things like the Perseverance rover that just landed.
Yeah, speaking of those planets you mentioned, Venus and Titan is what is this moon of one of the planets, right?
Yeah,
Whatever it
so
is.
Titan is an interesting one. You'll hear a lot of people say, that like Titan is very much Earth-like, and it's like Earth was early on in its history. That's really not true. The most Earth-like planet in our solar system is Venus. Even though Venus now has a runaway greenhouse effect going on, it has this very thick and dense atmosphere, a super hot surface, very dense surface, a very high pressure surface. Venus, long ago would have been the best culprit for being more Earth-like. But what we see on Titan is a really interesting organic chemistry occurring. Titan also has a very thick atmosphere, and where we have a hydrological cycle with water, Titan has a methanological cycle with methane and ethane lakes, methane and ethane going up into the atmosphere and evaporating and condensing into clouds and hazes, interacting with sunlight and making all kinds of cool organic molecules that are then raining back down onto Titan. And so Titan has really cool chemistry, but as far as the physics of Titan goes, the surface of Titan is extremely cold. It's even colder than dry ice. Than solid carbon dioxide. The surface of Titan is extremely cold, cold to the point where we think biological reactions, as we know them from life, probably aren't occurring at the surface of Titan. But Titan also has the potential to be an ocean world. So much like Europa has an ocean under its icy surface and Enceladus has an ocean under its icy surface, Titan may also have a water ocean down below its ice. And if there is any communication, is the word that we use, if there's any connection between that ocean and the surface, then Titan also has this reservoir of organic goop at the surface that could then get into that ocean and supply it with some of the necessary energy and some of the necessary chemistry for life. And so when we talk about life at Titan, most of us aren't talking about life at the surface of Titan. We're talking about the potential for subsurface or even ocean life on Titan.
So, if you had a chance to fly to any of these places to check yourself, which place would that be?
Oh man, that's a really good question because, so like from my personal standpoint, I would choose Mars because if I could go myself, and do the research, I would choose Mars because one, it's been a dream of mine since I was a kid to see humans on Mars and to walk on the surface. I've been an analog astronaut and have done things like the Mars Desert Research Station in Utah, where you go on a 2-week cruise simulation and you pretend that you're on Mars and you wear a spacesuit to go outside into the desert and do work.
Wow.
I would really enjoy that experience, from a human standpoint. I would enjoy walking around in a spacesuit on the surface of Mars, collecting samples and learning more about the geology and potential, past biology of Mars. But if I, had, unlimited funding and I could send a mission anywhere in our solar system to look for life, it would be Europa. I really love Europa. It's a large moon. It's almost the same size as our moon, actually. It orbits Jupiter. It has this very thick icy crust that's maybe 10 kilometers, maybe 6 miles or so thick. And then down below that ice is an ocean that has more water in it than all of the oceans on Earth. If we take all of the ocean water and lakes and rivers and streams and glaciers from Earth, and we take that volume of water and compare it to the volume of water in Europa's ocean, Europa is way, way more water than we have here at the surface of Earth. And Europa could potentially have things like hydrothermal vent systems, Those black smokers we see here on Earth at the bottom of our ocean, these really beautiful biological oases on the ocean floor with really cool chemistry and physics going on, where ocean water is like circulating down into the ocean crust. It's being heated by the mantle down below and then coming back out. And when it comes out, it's bringing along like a lot of just metals and chemicals that are rich for life to use with it. And if life can originate in an ocean, and we still don't know if that's possible. We don't know if life on Earth started in the ocean or on land. There's very active debate in that realm. But if life can start in an ocean, especially around a hydrothermal vent, and Europa has that much volume of ocean and that much of a seafloor as well, maybe Europa has a very active biosphere down in that deep ocean. And so if I had unlimited funds, but I had to plan a mission here in our solar system, I would go and send a very large scale mission to Europa to drill through the ice and get down into that ocean.
How many light years away is Europa?
It's not light years. So Europa is kind of still in the light minutes kind of
Oh,
realm.
really?
So
Okay.
you think, about how far we are from the sun. We're one astronomical unit, 150 million kilometers, about 93 million miles. It takes light from the sun about 8 minutes to get to us. So this will never happen, but it happens in science fiction stories sometimes. But if the sun shut off for some whatever non-physical reason that can't happen, it would actually take 8 minutes before we knew about it, which is kind of cool to think about. And so you think, we're one astronomical unit away from the sun. Jupiter's about five times further from the sun. So 5 astronomical units from the sun, and Europa is orbiting it. So we're still kind of in that range of light minutes. And so, it's not that far away from us, but for us to send a spacecraft there using our current propulsion technologies, we're still in that, 3, 4, 5, 6 or more year kind of realm to get there. So for instance, there is a mission in planning right now to go to Europa called Europa Clipper. And this mission won't be drilling, it won't be landing, but it will be orbiting around Europa and Jupiter together and doing a lot of really cool science, showing us more about the surface of Europa, getting better measurements on the actual depth of that ocean, the depth of the ice, looking for potential plumes of water coming out, looking at the radiation and chemistry, the environment around Europa, and getting really cool maps, chemical maps, and visible camera maps of Europa's surface. This mission is supposed to launch in 2024. And right now, we're not exactly sure which rocket is going to launch it. It could be NASA's Space Launch System, or SLS. It could be, a heavy launch vehicle from SpaceX. Currently, it's fairly open that there could be other competitors. But to launch in 2024, it's most likely going to be SLS or SpaceX, one of those two. But that mission, if it was on SLS, it could be like 3 or 4 years. If it goes on, another rocket right now, it might be like 5, 6 years. And so we're looking at something like 2030 by the time that mission even gets out there.
Wow, we should definitely have a second episode on this podcast and talk about the founding of that. But
Yeah, yeah, it's going to be a very cool mission. I'm looking forward to it, but there's this thing too, like in space exploration, where you can't just like click your fingers and have the mission get there. A lot of these people who are involved in these missions often are decades in duration. There's many years of planning and development and building their teams, getting the mission selected, and then building the mission, having the instruments selected, launching the mission. And then when we're going to the outer planets, to Jupiter, Saturn, Uranus, and Neptune, it takes years to get out there. And then by the time the mission gets there, then we actually start the science, and we can actually start taking the data and start learning more from these missions once they get there. And then that by itself could be, a few years or many years. And then, the data continue on. Young people, researchers from around the world will start accessing the data and using it to learn more, and might even base their careers in that data. So these missions, each of these missions is super impactful, and they have these long lifespans. I think some people are kind of unaware of how long these missions are really going on for.
yeah, I had no idea. You just introduced um, bureaucracy to science fiction, and I'm like, oh, this looks pretty pretty awful. Like takes so long. I didn't realize it takes that long.
Mhm.
So when this mission take place, right? Who has access to all this data? Everyone?
So there's a little interesting, so there are some politics that go on there a little bit. So those who are involved in the mission, those who are on the team, who are involved in the science, they will be the ones who get the data first.
Hmm.
And they're the ones who, they get the data first. They can then take the data, analyze it, make their interpretations, publish their papers. But these missions, NASA missions, missions from, most other space agencies, the data are accessible to the public. And especially one thing I really love with NASA a lot is oftentimes, especially with images, they just drop raw images in onto the internet so that people can access those images and start using them.
Yeah.
But like you might have seen recently with the Perseverance rover, which just landed on Mars, all those images are coming down. You can go to the Mars 2020 website from NASA and you can find the raw images. And if you're interested in image processing, there's a lot of really great people out there who've built careers on processing images from NASA spacecraft, even though they've never actually worked for NASA themselves. But those images do go to the imaging team and the science team first. And so that they get a chance to see it all first and, and make any interpretations they want to. If there's something really important they want to share first, they can do that. And then the data come out to everybody else.
So I have a feeling that your browser has a bookmark on that Perseverance on the
Of course.
regarding Mars. So speaking of Mars, there is this idea of colonization of Mars. Like, what does it take from the point of infrastructure to put people out there and live a fairly normal life?
Yeah, getting humans to Mars, settling on Mars as humans is something that like I mentioned, I've dreamed of since I was a child is walking on Mars. And I've done analog missions. And, we don't just have the Mars Desert Research Station. There's also High Seas in Hawaii, the Flashline Mars Arctic Research Station up in the Arctic, and the Houghton Mars Research Station. There's one in Israel. There's one, I want to say, in Oman. China is working on building one of these. We have all these Mars bases around the planet where people, not just scientists and engineers, but civilians, artists, musicians, philosophers, thinkers, they want to be involved in what it takes to get humans to Mars. And so they've been doing things like these missions and trying to learn more. And we've learned a lot over the years of what it might take for the psychology of teams working together on Mars. The pandemic has been a great time for us to test, being in isolation, not seeing many other people, having to use internet connections with a bunch of technical issues, to talk to other people. We've learned a lot. But when it comes down to it, Mars is not an environment that we evolved to live in. Mars does not have a surface that is friendly to human life by any stretch of the imagination. The atmosphere on Mars is extremely low pressure. It's mostly carbon dioxide. Mars is extremely cold. The average surface temperature of Mars, I think it's about negative 90 degrees Fahrenheit. Now that does shift. There are some times where it's much warmer and even much colder, but negative 90 Fahrenheit is still very cold. And the radiation environment at Mars is much higher than we have here. And so all of us experience some level of natural radiation. We evolved in a radiative environment. The rocks beneath our feet, the materials that build the walls of our homes, even your food. There's radioactive material in your food that you eat every day. But our bodies are evolved to deal with the small level, the small dose that we get here. But we're very lucky. Our Earth has a magnetic field that really shields us from a lot of the radiation that could be hitting the surface of our planet. And Mars doesn't have that. Mars has a little bit of magnetism still in place from some of the rocks, but it doesn't have a large global magnetic field like we do. And so there's a lot more radiation from the sun and from cosmic rays hitting the surface of Mars. And so astronauts and early settlers who go to Mars to live, to explore, they're going to have to find ways to deal with that radiation environment, to deal with being in a super cold, different kind of atmosphere environment. And so they'll be wearing spacesuits to go out onto the surface. They'll have to live in habitats. When it comes to things like, how do we get food on Mars? We've thought a lot about, we can't afford just the sheer cost of sending all of our food there would just be a huge amount of money, a large resource consumption for us to do that. So people have thought, how can we grow vegetables on Mars? Maybe in the not too distant future, the question might be, how do we grow lab-based meat or lab-based fish, for instance, at the surface of Mars, along with our greenhouses that we're using to grow our food? And even right now on the Perseverance rover, there's a test instrument on board the rover called MOXIE. what this instrument is going to do, it's a test for what's called in situ resource utilization, or ISRU or ISRU. This process, in situ resource utilization, means using the resources that are in place at the surface of Mars for our human activities. And so what this instrument is going to do, it's going to take the carbon dioxide from the Martian atmosphere. It's going to go into the instrument, and it's going to use something called electrochemistry to split the carbon dioxide apart. Carbon dioxide is a carbon atom with two oxygens bound to it. This electrochemistry is going to break it apart into carbon monoxide, and it's going to make oxygen. And so that carbon monoxide can just blow away. That's not good for us humans to breathe in, of course. But the oxygen is very beneficial to us. So we can use that oxygen then to make breathable atmosphere for astronaut explorers on Mars, or for early human settlers on Mars. And we can also use that oxygen as an oxidant for our rocket fuel, for getting back home from Mars. And so MOXIE is a really important test of the kind of technologies that we'll need to use in place at the surface of Mars to get humans living there.
Is it possible, and I might miss it within your jargon, is it possible to recreate the atmosphere or something like that? Or it always has to be something, as you said, habitats?
Yeah, there's this idea called terraforming. I'm sure your audience, at least some people have heard of this before, this idea of making a world Earth-like. And we've heard about it a lot in science fiction. You've probably seen movies where there's terraforming going on. If you watch the show Firefly, they talk about how, they dropped in these instruments to terraform various moons and planets before people went there and started mining and living. You might have seen it in various movies where worlds have been altered to be more Earth-like. But the idea has a lot of scientific merit. And we've thought for a long time, like, how could we terraform Mars? Should we terraform Mars is also a really important philosophical and ethical question. But we do know that we could begin terraforming Mars. There are still issues with that. For instance, again, Mars doesn't have that magnetic field to protect it from radiation. It also lost its atmosphere long ago, and part of the reason for that is because it lacks that magnetic field. Part of it was just stripping away of the atmosphere over time, and also as it cooled down more and more water went into permafrost or was slowly stripped away. And so building a new atmosphere on Mars might not be an easy undertaking. And so there are people who are actively thinking about it. And oftentimes you hear people saying how it would take thousands or tens of thousands of years to terraform Mars. And that's entirely okay. It's okay for us. I think we humans really do need to start having long-term plans on how we interact with our world and other worlds. But again, I think a very important question before we begin terraforming is really to come together and have the conversation as to whether or not we should be terraforming Mars.
So the idea behind colonization in general is, if something happens to Earth, then we have a place to go, right? What are this something?
I'd say yes and no. So I will say there are some people who do that, who say that, if something happens to Earth, we need to have, a presence on other worlds. But right now, if we start sending humans right now to Mars, we're not going to have a sufficient human population on Mars that can live without the support of the Earth for a very long time. And I love how you see this in the novels and the television show of The Expanse, where you have Earthers, the Martians, and then Belters. And the Belters, they have their own little economy going on, but they are still very reliant on the Earth. And you see that in the most recent season. I don't want to give too much away to your audience if they haven't watched the recent seasons of The Expanse, but if you've read the novels especially, you've seen this where the Belters, some of them are so tribal and so hateful of Earth and Mars that they're entirely unaware that they cannot survive on their own without the Earth. And so I am one of those who would argue that there is no planet B. There is no plan B is kind of the joke there. We really should not give up on the Earth. So going and settling on Mars, building human settlements on Mars isn't inherently about having an alternative option in case something happens here on Earth. I think the real reason, at least for me, to go and settle on a place like Mars is for the human spirit, for the endeavor of doing it. We are curious beings. We've been wanderers throughout our entire history, and we're going to continue being wanderers, and we're going to continue being explorers and being curious. And so I think a big thing about going to Mars and settling there is just for the human endeavor of doing it. However, maybe in a few centuries or a few millennia, maybe we actually will start developing more sustainable human settlements, maybe even cities or nations on Mars and other worlds. Maybe at that point we could actually be like, oh well, something happens to the Earth and we have someplace else, but as of right now, we need to really do our best to take care of the Earth rather than having any other plans.
And it's cheaper too, I guess, right?
It's way cheaper,
Considerably.
and like the Earth is our cradle. The Earth is our birthplace. It'd be like if you want to go move into a new house, that's great, but you don't burn down your birth home. Like you sell it to somebody else who will also take care of it. Or maybe you drive back in your car once in a while and take a look at it and just to reminisce about the beauty of it. And so the Earth is our home. And when we start venturing out and settling in other worlds, if we become a multiplanetary species here in our solar system, and maybe, sometime in the not super distant future, maybe the next 10,000 or 50,000 years, maybe we will start traveling to other stars with new technologies that allow us to do that. And maybe at that point, we can come back to a conversation about whether or not we should call Earth home anymore. But right now, I mean, the Earth really is our home.
Yeah. You mentioned that mission to Europa. What are some other interesting missions that are taking place or about to take place that people are not aware of,
Oh
but
man,
you scientists are just losing your mind around about?
so many. There's always missions going on, and there's always missions upcoming that we are so excited about. We have two missions right now that are coming back to Earth with samples from asteroids. In our solar system, there's another mission coming up that's going to go to the asteroid Psyche, which is an all-metal asteroid. I have meteorites here in my collection. Even my wedding ring is a piece of metal meteorite
That's
that
fancy.
represents the core of an ancient planet, an ancient world from long ago that broke apart and put bits of its core out across the solar system to crash here for us to have for cool jewelry. But then
Does
it
it
was
give you any superpower?
it does not. However, I do like it more than diamonds. My wife and I both have pieces of the same meteorite, the same core of a once active world in our solar system on our
Wow.
fingers.
Wow.
But so Psyche is very cool. The mission that's going to go there is incredible. I mentioned Europa. So NASA has Europa Clipper. There's also the European Space Agency has the JUICE mission they're working on. That's the Jupiter Icy Moon Explorer. It will also study Europa, but it's also really going to focus on Ganymede and Callisto. The Dragonfly mission is coming up. That's going to go to Titan, and it's going to be so. Right now, we just put Ingenuity, the small drone down, the helicopter, on the surface of Mars from Perseverance. Well, it's going to be the very first powered flight test on another world. But Dragonfly going to Titan is going to have 8 propellers, and it's going to be about the size of a small car. And so it's a very big drone, and it's going to fly around in the dense atmosphere of Titan and land, do some cool chemistry.
Wow.
There's a whole bunch of cool space telescopes that are either gonna be launched or are in planning missions of various phases right now that I'm very excited for. I mentioned earlier, like James Webb Space Telescope is hopefully going to launch at some point. There are some others in the pipeline that might eventually get funded and go into space. You might have heard recently of that potential detection of the molecule phosphine in the atmosphere of Venus. And so there's a few different groups right now who are considering potential missions to Venus. NASA has 2 missions that they're considering right now that there are planned to go to Venus if they get selected. There's so many cool things coming up. There's always some cool missions down the pipeline for things that we can go, various places in our solar system. There's Bepi Colombo right now is going to Mercury, but it has to do one more flyby of Venus to get there, and so that's kind of cool. And then right now there's so much going on too with Earth observing satellites. The space around our planet is getting fuller all the time because of things like Starlink, but we also have just new and better Earth observing satellites going into orbit all the time. There's a lot of really cool stuff coming up very soon.
Yeah, I mean, my head is spinning. I mean, I'm sure you're excited. So, we discussed quite a few things already, but we haven't touched on those reports of UFO. What do you make of those?
Yeah, it's hard. You know, this idea that UFO means alien, you know, that's not new. That's been around for a while, but it really was because of science fiction. You know, it wasn't until we started having alien ideas in science fiction that people started saying that these things they were seeing were aliens. We didn't have any reports of alien abduction until it came around first from, you know, science fiction ideas. In 1895, Percival Lowell saw what he thought were canals on Mars irrigating water from the poles down to the equator. And so 2 years later, H.G. Wells wrote War of the Worlds and kind of launched alien invasion science fiction. And it wasn't very long later until we started having aliens being equated with these things that people saw in the night sky. And I personally, I never want to downplay someone's personal experience or their beliefs. I know for some people, they feel very, very certain that what they're seeing that they can't explain in the nighttime sky is alien. But when it comes down to it, to start applying some logic to it, I've personally seen things I cannot explain with chemistry and physics in the night sky. But just because I don't have an explanation for it doesn't mean that there is no explanation that we have as humans for it, nor does it mean that there couldn't be some explanation that we're not there yet. And so I think we should be exploring these things. And recently, my colleagues, Ravi Kaparapu and Jacob Hock-Misra, they wrote an article in Scientific American arguing that we should actually be studying these things more scientifically. You know, we don't know what some of these things are, so we actually should try to figure it out. And the term we use now for these things is unidentified aerial phenomena, or UAP, because not all of them can be proven to be objects. You know, sometimes they are. Sometimes it's an airplane that just, you know, the light is like glimmering off of a window from some sunlight up high and kind of shining, and it looks like something, but it's actually just an airplane. It could be a weather balloon. There's lots of those in the sky. I mean, amateurs can launch their own weather balloons with the GPS and cameras to get up very high in the atmosphere now. You know, there's a lot of things it could be. There's a lot of drones out there now. So, you know, drones have increased the number of people reporting seeing these UAP. But there's also other things. There's a lot of phenomena of light in the atmosphere that we're just starting to learn more about. You know, there's things like red sprites, sundogs, 22-degree halos, all these different things that go on in our atmosphere. Some of them we have physical explanations for, and some of them, you know, maybe we just aren't there yet. And so we should be studying these UAP more. But personally, and the one reason I don't think it's aliens, it's, you know, it's because I don't think it can be aliens. And here's my argument for why. So say there is an advanced extraterrestrial intelligence civilization out there, and they have the technology to travel through interstellar space. So they're obviously more advanced than us, at least in some areas in technology. They can travel through interstellar space, and they can use spacecraft to do so, and they can come here to our world and they can study us. You know, and maybe they would have reason to. Maybe, you know, you see Star Trek. We have the Prime Directive in Star Trek, and there's all these different stories in Star Trek where we humans are monitoring other, you know, less advanced species, waiting for them to be ready to have the galactic conversation about what it means to be, you know, a more advanced being. But if these aliens have the technology to come here, and they have the technology to remain so well hidden most of the time, it doesn't really make any sense that they would get caught. Uh, just it seems like it'd be a really stupid move, right? It seems like, how could they be that dumb to
Well,
get
maybe a
caught?
couple of teenagers borrowed the father's car and boom,
Went
you
out for
know?
a ride. Yeah, so those images we're seeing are just some alien kids joyriding. Maybe, you know, but
Yeah.
I think for me personally, I would rather exhaust the possibility of explanations. You know, and not saying it can't be aliens. I would never throw that off the table. I think we should consider that possibility, and we should explore that as a possibility. If that's happening, how can we test that scientifically? Is there a way to show that it actually is some extraterrestrial beings doing this? But so far, the evidence just doesn't seem to point to that, at least for me. But you know, again, like I'm a huge science fiction nerd. I have been for a long time. If it is aliens, that'd be kind of cool.
Yeah.
And you know, maybe they are. You know, maybe one of the reasons we haven't found alien life yet is because they're just waiting for us to get our act together, to grow up as a civilization and to start being better to our planet and better to each other, to build some better technologies. And maybe they'll just like all of a sudden turn off all their cloaking devices and say hi. You know, who knows?
That'd be cool. So, I mean, that's been fantastic. Thanks for all this information. So, one personal question I had for you. So, you've been doing this quite for quite a long time, right? Um, Typically, when you do something for a long time, you have dreams at night about certain things, right? About these things. What's the most common dream you have? What's the most exciting one you have?
Yeah, so that's a very, very fun question. My dreams, I'm not just an astrobiologist. I've done lots of different things. My academic background was in biology, chemistry, astrophysics, and geology. I've been blessed to have the chance to travel around the world to do some very cool science. Just later this year, I'll be traveling to India for roughly a month. I'll be a resident scientist in the Earth and Space Exploration Program being run by Cosmic Adventures and Amity University in the Ladakh region of India. And so travelers, explorers who want to come to India and learn about planetary science and astrobiology and climate change in this region at the foot of the Himalaya, they can come on week-long trips, and myself or one of the other resident scientists will teach them about science. And so in my dreams, I dream about the places I've been and the places I want to go on the Earth. I dream about, these really cool, travel experiences, being on mountains, being down in the ocean, scuba diving. There's so many cool things about being human and experiencing our planet. When it comes to my dreams about alien life, as much as I am a science fiction nerd, I don't really have that many dreams where I'm like on a spaceship or doing like the Captain Kirk, sitting back in the commander's chair as the ship travels somewhere. However, I have had a lot of dreams where I'm on like an alien world or in an alien biosphere, and there's different kinds of creatures, moving around me that are animal-like or plant-like, and those kinds of things. Because I've spent a lot of time just wondering, we have so much biodiversity here on Earth. There's one estimate that we might have more than 1 trillion species of organisms here on the planet. And life does incredible things on our world. I mean, so many beautiful things from swimming and flying, walking in various ways, all these weird ways to get energy, to reproduce, weird colorations, weird body plans. There's so many cool things that life does. And so for me, I've often wondered, if we find an alien planet, how varied will its biosphere be? How different will it be? Or how similar? And so my dreams, when I dream of alien life, it's usually more in that vein. It's, what would an alien planet be like for us to be there and experience it?
Well, that's fascinating. So for people who want to learn a little more about what you do, is there a website or a blog that you can point them to?
Absolutely. First off, I'm all over on social media. People want to find me. I'm on Twitter and Instagram at Cosmobiologist. I'm on Facebook and LinkedIn at Astrobiologist. My website is cosmobiota.com. That's COSMOBIOTA.com. And then I also host the show for NASA Astrobiology called Ask an Astrobiologist, where once each month I bring another astrobiologist on the show and we have a conversation about their career, about their research, about their hobbies. And then we open it up to the audience, and the audience can ask questions, usually in the vein of the research of the guest who's going to be on the show. For instance, my next guest is Dr. Jen Blank. She's a colleague of mine from my research institution that I work for. She's also just an incredible explorer. She's also been around the world to some very cool sites. She's the primary or principal investigator, or PI, as we say in the lingo. She's the head scientist basically on a project called Braille, where they're exploring lava tubes and caves using all kinds of really cool robots, including a robot from Boston Dynamics. I don't know if you've been watching their robots.
Yeah, those are hilarious.
Yeah, so, they're walking robots. They also have the dog. And so she has one of the robot dogs they brought into the caves to do some science. And so Boston Dynamics is doing some science too, besides just building these really cool robots. So if you want to learn more about that, you can watch my show, Ask an Astrobiologist. I have lots of different people on the show who are involved in astrobiology, from science and engineering, philosophy, all kinds of different realms. And so it's also, a cool place to come and ask questions.
Got it. Dr. Lal, thank you very much for being on the podcast.
Yeah, thank you. I appreciate having me on.